Okay, so let's look at how to find the feasible region given a system of equations. So there are four inequalities here that we need to consider. Looking at these last two, these are our non-negativity inequalities. So that means that our feasible region is restricted to the first quadrant. So just starting with these first two, I know automatically I'm stuck in this first quadrant. The next thing we'll do is look at each one of these individually. So we need to graph our boundary lines 3x plus y equals 6, and then we're also going to have to graph x plus 2y equals 7. Very quickly, I'm going to go ahead and determine what the x and y intercepts for each one of these inequalities are. That way I'll know how to appropriately label my graph. So I'm going to start with letting x be equal to 0. When I do that, that makes my y value equal to 6. And when I let y be equal to 0, cover that one up, that makes my equation say 3x equals 6, divide both sides by 3, and my x-intercept is 2. Same thing over here. I'm going to let x be equal to 0. When I do that, I get 2y equals 7, divide both sides by 2, so y is at 7/2 or 3.5, and when I let y be equal to 0, then my x value is equal to 7. So I know for my x and y intercepts, I need to go to roughly at least 7, because that's where this x-intercept is for my second equation. So I'm going to label my graph. I'm going to go to 10. Okay, so starting with my first equation over here, I'm going to make my line. So x-intercept at 2, 0, y-intercept at 6, 0. Connect the dots. So this is my boundary. It breaks my graph up into two pieces. On one half of this line, I have all of the ordered pairs that will make my inequality true. On the other half of the line, I have all of the ordered pairs that will make this inequality false. So to decide which side of the line has all of the ordered pairs that make this inequality true, I pick a test point. And the easiest one, if you can use it, is 0, 0. So I'm going to test 0, 0 in my first inequality. So plug in that ordered pair. I get 0 is greater than or equal to 6. And this is a false statement. So that means the side of the line that has that ordered pair 0, 0 is not where the solutions to my inequality lie. It's actually up here on top of my line. So this is the area of the graph that makes that first inequality true. So move on to the second inequality. Go ahead and graph your line. So we have a y-intercept at 0 and 3/2, and then also at 7, 0. Connect your dots. Same thing here. We're going to test to see which side of this line has the ordered pairs that make this second inequality true. So test 0, 0 back into your original inequality. So plugging it into this thing, and I get 0 is greater than or equal to 7. This is false. So we're going to shade the side of this line that does not have the point 0, 0, which is above the line. So where is the solution region? Anywhere where all four of these are true simultaneously. So when we just drew the first quadrant, that took care of where these two were true. Now we need to look to see where the other two are shaded at the same time. And I didn't mean to make a circle there. But from here, down to here, over here, and beyond. So this area right here is the solution region for this system of linear inequalities.